Okay, I think we're going to get started now. Let me just give you a brief rundown of what we're going to be doing. If you recall, I said last week that I'm going to be giving you another test on Delta Math. It's going to be available Thursday after class. Today we're going to be doing some review for that test. Then we have finished the first 4 chapters in the text, which is what is covered on the midterm. So we basically finished the material for the midterm. So after the quiz on Thursday, there is going to be, I'm going to spend some time reviewing for the midterm, and then I'm going to give you a test on Blackboard that's going to be similar to what the way the midterm will be given. So you'll have some idea of how to handle a test on Blackboard. Again, I'm going to give it to you after I have finished reviewing the material that will be on the midterm, because that test will be sort of like a pre-midterm. It'll be on all the material that would be on the midterm. It'll be 20 multiple choice questions, just like the midterm will be. Today we are basically completing our study of quadratic equations, which we pretty much completed last time, but we're going to do some more of those examples. And then we're going to do review for the test. And on Thursday, we will begin chapter 5, which it will not be included in the midterm, but we have to continue with the material so that we can finish everything before the final exam. Let me just remind you that we do have a wonderful SI leader here. Her name is Shireen, and she's here in class with us, and she has been sending you emails as to when she is available for tutoring and helping out. Certainly, if you're having any kind of difficulty with anything, she is the go-to person. I am only available Tuesdays and Thursdays from about 9:15 until 10 on Zoom, but she's available much more and will be much more helpful.
I'm not a lazy man, no. If I may
Which one of y'all cut the cake and made all that mess on the table and then left?
Professor.
Yes. Hello?
If I may add, I also posted a list, a schedule for every other SI. If you guys have classes like English or Bio, on your Blackboard there's a file marked SI sessions for Math, Bio, and English. You could check there for schedules that suit your that suits you. If you can't attend my times and set my time.
Okay, so where did you post that, Shireen?
I posted where you normally post most of the information.
Oh, okay.
On Blackboard.
On Blackboard, great. Okay. I can't tell you what a help Shireen it has been for many students. That I have had several students that would never have passed the final without Shireen's help. So really, if you're having any kind of difficulty at time, get in touch with her. As a matter of fact, what I will do, if anybody did not do well on the first test and would like to take it over, if I will allow you to do it, if I get an okay from Shireen that you have gone over that material with her. I mean, there's no point to take the test again if you haven't learned how to do the examples. But if you tell her which examples you had trouble with, she'll go over those with you, and then I will reset your Delta Math test so that you can take the test over again. There is, again, this next test. The next test is on chapters 3 and 4, which is systems of equations. We're going to be reviewing that, systems of equations and polynomials. Yes.
Is the midterm going to be on Delta Math?
No, the midterm is going to be on Blackboard. That's why after this test on Delta Math, I'm going to be giving you about a week later or so a test on Blackboard. It's going to be a multiple choice test like the midterm is going to be. Very similar to the midterm, okay?
When is the midterm?
I don't have the exact date yet. It hasn't been settled, but it's usually, we're now in week, today is the 11th session. It's usually after about the 14th session. So I am thinking of giving you this test next week on Blackboard, this test for you to do. Again, it's going to be outside of class, but it'll be a time test. I'll give you more information on Thursday about that. And I hope by Thursday I will have more information as to when the midterm is going to be as well. Is everybody okay in that?
Yes.
Okay, so let's get started by reviewing the examples on practice sheet 4 that we haven't completed. I don't know if I'm going to be able to go through all of them, but I'll go through a bunch of them so that as a review of what we've done already for chapter 4. So this is on factoring and on quadratic equations. All right, one of the examples that we had to do was number 13. I'm not sure if I signed it now, but at some point we did have number 13, and we did it partially, but we never really completed it. So I'd like to review that. Number 13 reads 6x to the 4th y squared plus 18 x to the 3rd y to the 3rd minus 24 x squared y 4th. And what they asked me to do is factor. And whenever I factor, the first type of factoring that I always want to look for, even if it's not said factoring completely, you want to do this. What you want to look for is a greatest common factor, a number or letter or combination of numbers and letters that you'll be able to factor out of each term. And if I look at the numbers, the coefficients, I have a 6, an 18, and a negative 24. The largest number that goes into all of them is 6. We're always looking for the greatest common factor. Even though 3 works and 2 works, the largest number that works is 6, and that's the one we want to use. Then we look at the variables, x fourth, x cubed, and x squared. Those are the x's. The lowest exponent I see is an x to the 2. That's our common factor in the x's. In terms of the y, I have a y squared, a y cubed, and a y fourth. So y squared is our common factor there. So our GCF, our greatest common factor, is 6x squared y squared. We're going to divide each of the first terms, the original terms, by this common factor. So 6 into 6 cancels. X squared into X fourth gives me X squared. Remember, you're subtracting the exponents. Y squared into Y squared cancels out. Then I go to my next term. 6 into 18 is 3. X squared into X third is X, because my exponent becomes 1. Y squared into Y cubed is Y. And finally, 6 into negative 24 is negative 4. X squared into X squared cancels. Y squared into Y fourth is Y squared. And I'm left inside my parentheses with a trinomial. And what we have to do is try and factor that trinomial as well. Now, remember what I told you, when you have trinomials that have two variables, sometimes it's easier to look at it by just eliminating or leaving out one of the variables. Let's leave out the second variable, the y. And we'll get x squared plus 3x minus 4. And factor this. Now, this is a trinomial, and it starts with a leading coefficient of 1, so I can right away open up my two parentheses, and x squared I'll break up into x and x. And remember, then we look at our last term. It's negative. That means one of our signs is going to be positive and one is going to be negative. And we're looking for numbers that multiply to 4, and when we subtract them, we get 3, and that could only be 4 and 1. And since the 3 is positive, the middle term is positive, my larger number, the 4, is the positive. The smaller number, the 1, is the negative. But we really wanted to factor the x squared plus 3xy minus 4y squared. Just stick in the y's at the end of each parentheses, and you will have correctly factored this trinomial. Notice x minus 1y actually could just be written as plain y. Was probably the better way of writing it. Usually we don't write when we have a coefficient of 1, we usually don't put it in. Don't forget that there was a 6x squared y squared as a common factor. So this would be your answer to question number 13. Okay, so now let's look at question number 19. It says factor the trinomial 9r squared plus 15r plus 4. Okay. So again, we're always going to look for a common factor, but if you look at it, there's a 9, a 15, and 4. There's no number that goes into all of those, except for 1, and we really don't usually write a common factor of 1. And of course, the last term doesn't have r, so there's no variable either. So we have to do what's called the AC method, because the number in front of the r squared, the leading coefficient, is something other than 1. What we do is we multiply the 9 times the 4, which will give us a plus 36. And what we want to do is find two numbers that multiply to 36. Well, let's first look at the sign. The sign is positive, means that we obviously have to have two numbers that are the same sign. The middle sign being positive means both of those numbers have to be positive. So we need two numbers that multiply to 36. And when we add them, because this is positive, we're going to get 15. Well, let's think of what numbers multiply to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9. I'm trying to think. 6 and 6. There's a lot of combinations. But that's, remember, we know that they have to add up to 15, so it must be the 3 and the 12. So what I'm going to do is I'm going to rewrite this trinomial into 4 terms. I'm going to leave the 9r squared alone. The 15r I'm splitting into 3r and 12r. 3 and 12 are for the 15. We know to split it that way because of the rule. And then, of course, plus 4. You just bring that down. And we're going to use grouping. In our first group, there's a common factor of 3r. So therefore, I'll get 3 into 9 is 3. R into r squared is r. 3r into 3r, everything cancels out. Remember, when everything cancels out by factoring, you don't leave it blank, you put a 1 because you're dividing. Then we go to the next group, 12r and 4. Well, obviously 4 goes into both of those terms, and since this middle sign is positive, it's a plus 4. You always have to put a sign, whether a positive or a negative, and you have to put a number. If there's no common factor, you have to put in a 1, because there always has to be a number on the outside of that second parentheses. Now, 4 into 12r is 3r. 4 into 4 gives me 1. So my common binomial factor is 3r plus 1. And the other factor are the numbers that are outside the parentheses, which is the 3r plus 4. And this is the factorization of 9r squared plus 15r plus 4. And again, you could see if it was correct, because if you did FOIL on these two binomials, you would come back to this. Any question about this? Okay, so let's go on to the next. Another example. Let's look at example number 24. It says factor completely 25m squared minus 20m plus 4. And again, the first thing we always look for when we're factoring is a common factor. But if you notice, there is no common factor. Nothing goes into 25, 20, and 4. And the letter doesn't extend to the last term. There's no common factor. So we're going to do what we did before. We're going to try and do our trinomial factoring. And again, since there's a leading coefficient of 25 here, I'm going to have to use what's called the AC method. I'm going to multiply the 25 times the positive 4, which will give me positive 100. Now, first of all, I'm looking for two numbers. Let's think about the sign. This sign is positive, so both numbers have to have the same sign. Since the middle sign is negative, it means both of them are going to be negatives. And we're going to need numbers that multiply to 100, but when we add them, they're going to give me 20. Okay, let's see what we can multiply to 100. 1 and 100, 2 and 50, 4 and 25, 5 and 20. There are a lot of them. 10 and 10. I think this is pretty much all of them. Remember what we want them to do. They have to add to 20. So that must be the 10 and the 10. So it has to be a negative 10 and a negative 10. I'm rewriting this as 25m squared minus 10m and minus 10m, which means I've just split the minus 20m into two negative 10m's and plus 4. And now I can use my grouping because I have 4 terms. In my first group, between 25 and 10, common factor is 5. M squared and m is m. So 5n into 25m squared is 5m. 5 into negative 10 is negative 2, and the m's cancel out. So in my first group, I get 5m times 5m minus 2. Okay, we go to our next group. A 10 and a 4, the number that goes into both of them is 2. But since this number here, the 10, which is the leading coefficient of the second group, is negative, I have to use the negative as part of that common factor. So I'm going to have a common factor of negative 2. Negative 2 into negative 10m is positive 5m. Negative 2 into positive 4 is minus 2. And I see that my common binomial factor is 5m minus 2. And what's on the outside is a 5m minus 2. In other words, my factoring gave me 5m minus 2 times 5m minus 2, which could also be written as 5m minus 2 with a square on the outside. It's a binomial squared. Notice, if you looked at the original trinomial, the 25m squared was 5m and 5m. The positive 4 was negative 2 times negative 2. And the negative 20 came by multiplying these two together, 5m times my negative 2, and doubling it because you have an outer and an inner. So sometimes if you see the pattern, you might see that it is a binomial squared. But otherwise, just do it like the regular factoring that we've always done. Again, this is a correct answer, but probably if you were given a multiple choice test, the likelihood is that the answer would be given in this format rather than this format. Okay, so that's basically factoring, the type of factoring. And after we finished factoring, we talked about solving quadratic equations. So let's do some of these. These are examples 30 through 38. Let's do several of those examples that I had asked you to do for homework and see if you got them right. Let's look at number 30. Number 30 says 4x squared plus 12x equals 0. Okay. Now, and it says solve. When you have an equation, in other words, when you have an equal sign, and it says solve, or even if it doesn't say, but just says find the answer, you know it's an equation. And since it has an x squared term, it has an exponent of 2 in the problem, it's what's called a quadratic equation. And the one way we'll learn later on other methods, but the one method we've learned of solving a quadratic equation has been by factoring. We have to get our quadratic equation equal to 0. Well, we're lucky, it already is in that format. And then we have to set each factor equal to 0. So let's first factor it. 4x squared plus 12x. There's a common factor of 4x. I'm going to put a 4x on the outside, and I'm going to get x plus 3 inside. So step 1 in solving the quadratic equation, after it's equal to 0, is to factor. And then, after you've finished factoring, take each of your factors and set it separately equal to 0. Just a little hint. If they already give you the thing in factored form, if they had given us 4x times x plus 3 equals 0, I wouldn't have to have gone back to multiply together to then refactor it. If it's equal to 0, I just separately said each of the factors, the 4x equal to 0 and the x plus 3 equal to 0. If when it's in factored form, but the number on this side is not equal to 0, if it's equal to anything else except 0, then I'm going to have to remove the parentheses, multiply back, and get it equal to 0. So sometimes it's a really easy problem because it's already factored for you, but it has to be equal to 0 in order for you to go to the next step. Now, once you set each of these equal to 0, you then solve each of these equations. Well, this one I have to divide by 4. And anything, 0 divided by anything is always 0. So one answer is x equals 0. Over here, to get the x alone, I have to bring 3 to the other side. And I get x equal to -3. When you have a quadratic equation, you're looking for 2 solutions. Very, very seldom, but occasionally it happens that both answers are the same because both parentheses turned out to be the same. Then you only have one answer, but usually you get 2 separate, unique answers. You could also write it like this in brackets, 0 and -3. And it doesn't matter if you put the 3 or the -3 or the 0 first. There are though your 2 answers. So look for 2 answers when you're solving a quadratic equation. Again, you recognize a quadratic equation because it has an exponent of 2. It can be solved. Okay, let's try another example. Let's try example number 32. Number 32 looks like this. X squared minus x equals 30. Right away, it says solve. I see the equal sign. I know I have a quadratic equation because I have an x squared. And again, as I said before, when you have a quadratic equation, your first step is to get it equal to 0. And what you do is you look at your x squared term, and if it's positive where it's standing, then you don't want to move that x squared term. You want to leave it where it is. If the x squared term is negative, then you want to bring it to the side that will make it positive. It's always easier to deal with the factoring if your x squared term is positive. So since the x squared term is positive over here, I want to leave it here. That means I have to get the 30 to the other side. So this will give you x squared minus x minus 30. These are not like terms, so I can't combine them, equals 0. And now I'm going to try and factor. Why we spend so much time factoring, so that we can solve these type of equations. There's no number in front of the x squared. The leading coefficient is 1, so I can do this is the easier type of trinomial factoring. I put in x and an x and go to my last term, which is negative. Since this is negative, it means one number is going to be positive and one's going to be negative. And I need numbers that multiply to 30, and when I subtract them, remember there's an understood 1 over here, they're going to subtract to 1. And I think you all realize it's going to be 6 and 5. And the 6 is going to be the negative, and the 5 is going to be the positive, because the middle term is negative means my larger number is negative. Okay, now I've got a factor. Now I'm going to set each factor equal to 0. X plus 5 equal to 0. And x minus 6 equals to 0. And this one, I'll get x equal to negative 5. And this one will give me x equal to 6. So here are my two answers, negative 5 and positive 6. Don't guess at the signs. Make sure you do the work through so that you don't make a mistake on the numbers or on the sign. It's x equal negative 5 and x equals 6. Are we ready to go on to the next one? Okay, let's try another one. Okay. Let's look at number 34. Number 34 reads 3x squared minus 75 equals 0. Okay, so again, it's a quadratic equation because it has an x squared in it, and it already equals 0, so I don't have to move anything. So now I'm up to the factoring part. And the first thing I see is a common factor of 3. I put the 3 on the outside and I get x squared minus 25 inside my parentheses. And x squared minus 25 is that special situation that's called the difference of perfect squares. This is a perfect square, it's x and x. The 25 is a perfect square, it's 5 and 5, and there's a minus. So I can break it down into the two conjugate binomials, x plus 5 and x minus 5. And now we're going to set the factors equal to 0 because this is an equation. It says equal to 0, and we are solving this equation. Now there actually are 3 factors here. There's a 3, there's an x plus 5, and an x minus 5. Now, when you're multiplying things, it doesn't matter. Even if you're multiplying 100 factors together, if one of them is 0, the whole answer is 0. So any one of these 3 factors could be 0, except the first factor is 3, and 3 can never be equal to 0. 3 can only equal 3. It has no variable, so I don't try to set that one equal to 0. But I do set the x plus 5 equal to 0 to get one answer, and the x minus 5 equal to 0 to get another answer. This will give me x equals negative 5, and this one will give me x equal to 5. So I have 2 answers, negative 5 and 5. Sometimes it's written this way, plus minus 5, where a plus over minus means one answer is positive 5, one answer is negative 5. It's a quicker way of writing. It's sort of like a shorthand way of writing, positive 5 and negative 5. Those are your 2 answers in this case. Okay, so let's try number 37. Number 37 looks like this. 5x squared plus 4x plus 12 equals 2x plus 12. And again, it says solve the equation. And Again, I see that this is a quadratic equation because I have an x squared term. That is my key for a quadratic equation, which means I then have to set it equal to 0. Now, since this x squared term is positive on the left side, I want to leave everything on the left side because I like it where it's positive. So I want to get rid of this 2x, so I'm going to subtract 2x from both sides. And then I'm going to subtract 12 from both sides, so that I'm ending up with 0 on the right side. What am I left with over here? I'm left with a 5x squared. The 4x minus 2x is 2x. And the 12 and negative 12, those just cancel out. So I'm left with 5x squared plus 2x equal to 0. So that's my first step. I recognize that it's a quadratic equation, so I set it equal to 0. I then want to factor. And the first factoring I do is a common factor where I see an x as a common factor. Put the x on the outside, I have 5x on the inside plus 2. And now I separate. They're equal to 0. I set them each factor equal to 0. X equal to 0. Remember, a common factor can be equal to 0 if it has an x in it, not if it's just a plain number. The other factor is 5x plus 2, and we set that equal to 0. So here is one answer, x equals 0. Over here, to get this answer, I have to subtract 2 from both sides. I have to solve this equation. So I get 5x equals negative 2. And therefore, my two answers are 0 and negative 2/5. I think this, I know we didn't go through all of them. Is there any question on any of the other examples that we had done that somebody would like me to go over? Okay, so this was, again, through this topic is what is going to be on your midterm. Your midterm is going to be everything from the beginning of the term until through chapter 4, which is what we've just completed. Let me reiterate. We're going to be starting chapter 5 on Thursday. Again, I don't know when the midterm is. It's going to be, I would say, in 2 weeks, but I'm not sure. When I'm given the date from the department, I will let you know. But again, we're going to be practicing in class for this midterm. And remember, on Thursday after class, you will have your Delta test on the 2 examples, on the 2 chapters. The Delta test on 2 chapters, chapters 3 and 4. I'm going to be doing some review of chapter 3 right now. And after next week, I'm going to be giving you a test on Blackboard that's going to be a review. That will be a review of all 4 chapters. Now, somebody just said that they, can you, Kalusia, can you get in touch with Shireen? I don't know why you're not, can't get in, you don't have any access to it, because she was just talking about it, that, see if you can you get in touch with Shireen? She's here in class. Shireen, can you talk to Kalusia?
No problem.
Okay.
I know somebody told me that they had problems with their Blackboard, but I can't really do anything. Do anything about that. You would have to contact
The registrar, I would think.
yeah, you would have to contact registrar.
But in any case, you can get to the tutoring.
If anything, if you can't get onto Blackboard, you could always email me if you have any problem, and I'll try to like write out the detailed step by step on how to do the problem, because I know sometimes people have problem with Blackboard. So, and I can't really do it do any other platform but that.
Okay, so she wants your email in
Oh,
the,
sure, no problem.
okay, great. You have to be able to get onto your Blackboard account because the next test that I'm giving, the practice test for the midterm is going to be given on Blackboard because the midterm is going to be on Blackboard. If you are having any problem getting onto Blackboard, you must make some sort of arrangements and let me know, but also because I will send a note to the registrar, but you should yourself be in touch with the registrar. If you're not able to get onto your Blackboard account, you must let me know because that's how your midterm and your final is going to be given. Again, let me reiterate that the next test next week, there's going to be, I'll tell you on Thursday when it's going to be. But that test is going to be on Blackboard. It's going to be a multiple choice test. It's going to be 20 multiple choice questions, very similar to what you're going to see on the midterm. And what I'm going to be doing is the next couple of lessons be reviewing for that material because it's been a while since we started the term. I'm going to go back and do some questions that are going to be like the midterm. That is going to be your review. Your review is going to be that test, but also your review are the 4 practice sheets. Those 4 practice sheets actually are given by the department and give you an idea of what the exam is going to be like. But as I said, I want as a practice for you to get used to the way the test is going to be. I'm going to be giving you a test next week on Blackboard. Again, I will repeat that this on Thursday. So what I want to do now is I'm going to put some problems on the board for review. I'm going to give you time to do them. And find where I put them. And after that, we'll go over them. While you're doing these examples, I'd like you to, I will be taking attendance. So just listen for your name. Okay, so the first thing we're going to review from chapter 3. We're going to be doing a review on chapter 3. And what we learned in chapter 3 are systems of equations. So I'm going to be giving you 3 questions now on systems of equations that I want you to work on while I am taking attendance. Okay, question number 1 is this one. Solve the system of equations x minus y equals 5, 3x minus 8y equals 5. So we have 2 equations. X minus y equals 5 and 3x minus 8y equals 5. That's question number 1. Question number 2, again, is a system of equations where we're given x equals 2y my second equation is 2x minus 3y equals 3. So I'm going to give you time to do those two questions while I take attendance. Let's do these together and let's see if you got them right. All right, now we want to solve x minus y equals 5 and 3x minus 8 equals 5. These are both in what we call standard form, where the x's and the y's and the equal signs and numbers are all lined up. So I think the best way to do this is by the elimination method. And let's eliminate the x's. So in order to eliminate the x's, I'll multiply the top equation by 3 and the bottom equation by 1. Remember, I just look at the numbers. And then I think about the signs. Since both of these are positive, and I really need one to be positive and one to be negative, I'm going to use a negative sign with one of them. And it doesn't matter which one I use the negative sign with, as long as I use it with one of them, not with both. So I'm going to use the negative with the 1 and the positive with the 3. Multiplying the top equation by 3 gives me 3x minus 3y equals 15. Multiplying the bottom equation by negative 1, remember you have to multiply everything, will give me negative 3x, positive 8y, and negative 5. Now when I add the equations, 3x and negative 3x cancel. Well, that's what we wanted to happen. We wanted to eliminate the x's, we said. Negative 3y plus 8y will give me positive 5y. And 15 and minus 5 give me 10. And now I can solve for y by dividing both sides by 5. And I get y equals to 10 divided by 5, which is 2. Once we have what the y is, we can figure out what the x is by substituting it into either one of those equations. Let's say it's substituted over here. I'm going to replace the y by 2. So this will give me 3x. 8 times 2 is 16 equals 5. Bring the 16 to the other side. This will give me 3x equals 21. And that gives me x equals 7. So for the first question, my x came out to be 7. My y came out to be 2. We could also write it as an ordered pair, 7 comma 2. Remember, when you put it in parentheses, when you put it in that brackets, that curly parentheses, the order doesn't count. It just means it's two separate numbers. But when you're using the parentheses, it means it's an ordered pair. The first number stands for the x, and the second number stands for the y. So so we could write it separately, x equals 7, y equals 2, or we could write it as an ordered pair, 7 comma 2. How many people were able to get that answer? I hope a bunch of you were. What happened to my eraser? Okay, I'll see somebody answered that they got the right answer. Good. Okay. Okay, let's try another example. Okay, let's look at this example now. X equals 2y and 2x minus 3y equals 3. The way this is set up, I think I want to use the substitution method. When one of my equations either says x equals something or y equals something, that is a good setup for the substitution method. Saying x equals 2y means in place of x, I can use 2y. So in my second equation where I have an x, I'm going to put 2y. So this is going to be 2. Here's my x. I'm putting 2y in place of it because my first equation tells me that x equals 2y. Minus 3y equals 3. And removing the parentheses, 2 times 2y is 4y minus 3y equals 3. And 4y minus 3y is y, and I get y equal to 3. And now, once I know what y is, I know my x is 2 times y, so it's 2 times 3, which gives me 6. So the answer to this is 6 for the x and 3 for the y. Doing this using the substitution method was relatively easy. Okay, let's see if we can find an example, a word problem that we can use to practice. Okay, another example. Okay. Here is a word problem that we can also use to solve, use a system of equations to solve. Here's the question. Tickets to a local movie were sold for $10 for general admission and $6 for seniors. So there are two types of tickets being sold, $10 tickets and senior citizen tickets. Here's the thing, 190 tickets were sold, and the total that they got was $1,260. How many were general admission tickets? How many general admission tickets were sold? I'll give you a few minutes to try that on your own. Let's see if we can set up a system of equations that we can use to solve this. Let's call G the number of general admission tickets that were sold. And let's call S the number of senior tickets that were sold. We could call them X and Y. I'm just calling them G and S for this. Okay, what's our first equation? Well, the first bit of information we know is that 190 tickets were sold. Doesn't tell us anything about the money here, it's just how many there were. That means that the G plus the S, the number of general admission tickets plus the number of senior tickets, has to be equal to 190. That's our first equation. The next equation has to do with how much money was raised. How do we figure out how much money was raised? Well, the money that they get from the general admission tickets is 10 times G. If you have 20 general admission tickets, then 10 times 20, $200 is how much you're making on the general admission. So you have to multiply the number of tickets you have times the price of the tickets. So 10G is how much they're making on the general admission, plus 6X, that's how much they're making on the senior tickets, will give us the total of $1,260. So here is our system of equations. We now have to solve the system of equations, and I'm going to use the elimination method. Since it asks for how many general admission tickets, if I want that, then I want to get rid of the S's. So let's get rid of the S's. Otherwise, if I got rid of the G's, I'd figure out what the S's were, and then I'd have to substitute it in. But since they only asked me for the general admission, let's get rid of the S's. So I'm going to multiply the top equation by 6 and the bottom equation by 1. And I'm going to use a negative with one of them because these are both positive numbers, and it doesn't matter which one I use the negative with. So multiplying the top equation by negative 6 will give us negative 6G minus 6S equal, now I'm going to take out my calculator and use it to solve, to do the arithmetic. You are allowed to use calculators. I'm multiplying negative 6 times 190 is negative 1140. The bottom equation multiplying by 1 remains 10G plus 6S equals 1260. Adding these two equations, negative 6 and 10 gives me 4G. Negative 6S and plus 6S cancel out. Negative 1140 plus 1260 gives me gives me 120 positive. And now I just divide by 4. And that gives me G equals 120 divided by 4 is 30. 30 general admission tickets were sold. Obviously, most of the tickets were senior tickets. But that's all they asked is how many general admissions, so my answer is 30. Make sure you're answering the question that they're asking and not giving, let's say, the number of senior tickets when they ask for the general admission. Okay, Wendy, so you gave both answers, but really it just asks for the general admission, so you have to be careful about that, especially making sure you're giving the answer to the question aside from that. Any question about how to do this? Okay, so that is basically a review of chapter 3. Let's do some of the things that we remember. The test on Delta Math is going to be from chapters 3, Systems of Equations, and chapter 4, I'm sorry, which is our polynomials. Now, we did a lot of reviewing of factoring today, and also we reviewed solving quadratic equations. So let's see if we can spend a little bit of time reviewing some of the things we did at the beginning of this chapter, which involved adding and subtracting of polynomials and multiplying of polynomials. So I'm going to put again 2 problems on the board, and I'm going to give you time to try them. And then I'm going to review them. Okay, so here's the first one. It says perform the operation. The question is negative 3x squared minus 7x plus 1 minus negative 18x squared minus x minus 1. Okay, that's question number 1. Question number 2 is a multiplication. I want you to multiply x minus 5 times x plus 2 times x squared plus 7. See if you can multiply these 3 binomials. Okay, I'm giving you a few minutes to try these 2 problems. Okay, let's look at the first one. The first one is a subtraction example. What we want to do, remember when there's a minus in front of a parentheses, it's as if there's a negative 1 there that's being multiplied by anything. So removing this parentheses, we get negative 3x squared minus 7x plus 1. And over here, multiplying everything by negative 1 will give us positive 18x squared, positive x minus 1. Another way of looking at it is when you're subtracting, you're changing all the signs. Now all we have to look for is, can we combine like terms? And there's a negative 3x squared and a positive 18x squared, which gives us 15x squared. A negative 7x and a positive x, which gives us negative 6x. Remember, negative 7 plus 1 is negative 6. And finally, 1 and negative 1 cancel out. Remember, when you're adding or subtracting.
I have a question, sorry.
Sure.
Doesn't the negative make the negative 1 positive at the top? You see when you distribute it?
Sorry, yes, you do.
Yeah.
Thank you so much.
No problem.
Negative 1 times negative 1 should have been positive 1, and now I have a positive 1 and a positive 1, which is a positive 2. Thank you very much for keeping on top of me. All right, and that should have been your answer to the first question. Now, when it comes to the second one, we have 3 actual binomials that we're multiplying. When you're multiplying 3 things together, you can't do 3 at once. You have to do it 2. First multiply 2. We call multiplication, just like addition and subtraction, a binary operation. It's a 2-number operation. You want to do 3 things, you have to do it in steps. So first we have to multiply the first 2, get an answer, and then multiply the third one. And it doesn't matter which order you multiply. If you first wanted to multiply the x plus 2 times the x squared plus 7, or you wanted to multiply the x minus 5 times the x squared plus 7, first, it doesn't matter the order as long as you end up multiplying all 3. I'm going to do it in the order it comes. I'm first going to multiply x minus 5 times x plus 2. And I'm going to use FOIL. X times x will give me x squared. Outer, x times negative 2 is negative 2x. Inner, negative 5x times x is negative 5x. And last, I'm sorry, somebody's not following. X times positive 2 is plus 2x. I'm really making mistakes with my signs. Those are the easiest mistakes to make, and they count the most, because if you make a mistake on your sign, the whole question is going to be wrong, whether you know how to do anything or not. Let's do it again. X times x is x squared. X times positive 2 is positive 2x. Negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. And when I combine the like terms, that'll give me x squared. 2x and minus 5x is minus 3x minus 10. I still have to multiply this by the x squared plus 7. Now, I'm not going to be using FOIL anymore because this is a trinomial times a binomial. All I have to do is make sure to multiply everything from my first parentheses by everything in the second parentheses. So I'll start out with the x squared. I'll multiply the x squared times the x squared. Remember, when you're multiplying, you're adding exponents, so that becomes x to the 4th. Then I'll multiply the x squared times the 7. That'll give me plus 7x squared. I'll now go to my second term, negative 3x. I'll multiply negative 3x times x squared. That'll give me negative 3x to the 3rd. Remember, when you're multiplying, you're adding exponents, and this is understood to have an exponent of 1. Then I'm going to multiply negative 3x times 7, which will give me negative 21x. And finally, I'll multiply everything by the negative 10. Negative 10 times x squared is negative 10x squared. Negative 10 times positive 7 is minus 70. Okay, now I have to rearrange these terms so they're in the proper order. The highest exponent term is the x to the 4th. The next thing is an x to the 3rd. There's one x to the 3rd. I'm going to write negative 3x to the 3rd. Then we have x squared. Well, there's a set positive 7x squared and a negative 10x squared, which is going to give me negative 3x squared. Then we have minus 21x and minus 70. And that would be the answer to this by multiplying. And again, the whole idea is to multiply 2 together, combine your like terms, then multiply by the next one. Are there any questions on these? Any question about this? If not, then let me reiterate that on Thursday, we're going to be starting chapter 5. We also will be doing, part of the period will be review on chapters 1 and 2. If you have any questions on either of these topics, the topic of systems of equations or the topic of polynomials, that's what's going to be on the